Okay, I want you to just picture this for a second. It's a really cold day in Denmark. You know, that kind of biting cold where the air feels sharp when you breathe in?
Yeah, that frozen nostrils kind of cold.
Exactly. And the ground is just covered in this perfect, thick blanket of snow. And we were following these two young students, Kesser and Steen.
They're walking home from school, cutting through the woods, and they've just come from a class called Nature and Innovation, which, I mean, based on what they were thinking about, it was not a light and fluffy lecture.
No, not at all. But before we get into the heavy stuff on their minds, let's just stay with them in the woods. They're crunching through the snow, you can see their breath, and then they stop.
They see something.
Right. A perfect line of tracks right across the path. And Steen, who seems to be the tracker of the two,
Hmm.
he leans down and he just immediately says, "Oh man, that's a roe deer. Maybe a fawn from last year."
Which is just a lovely little moment, isn't it? Just these two kids, the silence of the woods, appreciating these little hoof prints. Eh, oh dear, mosconunge.
Exactly. But here's the twist. While Steen is looking at the deer tracks, Kesser's looking at something else, something right next to them. Just these funny little brown cones scattered on the snow.
Ella Kogler, elder
To
cones.
most people, that's just stuff on the ground you'd step on. But Kesser points them out. And this right here, this is where it all changes. Because those little frozen cones are, believe it or not, the answer to the terrifying problem they just learned about in class.
It's a fantastic setup. You've got the deer tracks on one side, which is pure nature, and then these seeds on the other. And Kesser is realizing right there in the cold that those seeds might be the solution to a huge environmental crisis.
So let's pause the walk and rewind. Why were these two so worried? What in the world did they learn in Nature and Innovation that would make a couple of alder cones look like a lifeline?
Well, the sources say they did a pretty grim deep dive of their own on the idea of blue babies.
Which sounds like something from a horror movie, but it's a real medical condition.
It is. The technical term is cyanosis, but yeah, blue baby syndrome is what sticks. It's a condition where an infant's skin, their lips, they turn this awful shade of blue, and it's caused by the water they're drinking.
And this is where the chemistry gets really scary. It's all about nitrate, right?
Correct. But here's the thing. The nitrate itself isn't the direct villain. The problem is when it gets inside the body, it converts. It becomes nitrate. It's NO euro. And nitrite is the real danger.
Okay, so what does the nitrate do?
It's basically a hijacker.
Yeah.
It gets into the bloodstream and it latches onto hemoglobin. Now, hemoglobin is supposed to be carrying oxygen all over your body.
It's the delivery truck.
Exactly. But nitrite binds to it even tighter than oxygen does.
Yep.
So it just shuts the whole delivery system down. The baby can be breathing perfectly fine.
But the oxygen isn't going anywhere.
Nowhere. The baby is essentially chemically suffocating from the inside. That's where the blue color comes from. It's pollution in the water causing it.
That is a horrifying thing to be thinking about on your walk home. And the class also talked about where all this nitrate is coming from. It's not natural, right? Not in these amounts.
No. We used to worry about, sewage from cities, but we've gotten a lot better with that. The source of this massive nitrogen problem, the stuff getting into the groundwater, it's almost all from agriculture.
The sources even pinpoint this specific danger zone in Denmark, in Jutland. They call it the nitrate belt.
Sounds like a terrible wrestling prize.
It really does, and it stretches between Grena, Silkeborg, Viborg, all the way up to Aalborg. It's a huge area.
And it's not because the farmers there are uniquely careless. It's geological bad luck, really.
What do you mean?
The soil in that belt is very sandy and gravelly,
Yeah.
and underneath that you have limestone that's full of cracks.
So not like heavy clay that would hold the water.
Exactly. Clay is a sponge. This stuff is a sieve. It's like a leaky coffee filter. So when farmers spread fertilizer, the rain washes it straight down
Past the roots, through the cracks.
and right into the groundwater. There's no time for the soil to naturally filter or process the nitrates.
And the scale of this it's just wild. The class looked at the numbers. In 1950, the nitrogen surplus, so the leftover stuff, was about 60 kilograms per hectare.
Which was, kind of manageable.
Yeah.
But by 1981, it had tripled, 180 kilograms per hectare.
What happened? Just more fertilizer.
That's part of it, cheap artificial fertilizers after the war. But the other huge piece was fodder, the food for the animals.
Ah, right.
Instead of just eating grass, we started importing tons of soybeans to feed the livestock. So you're basically importing nitrogen, feeding it to a cow, and then spreading all that concentrated nitrogen back onto the leaky soil.
It's a cycle that just dumps it straight into the tap water.
Precisely. And that's what has Kesser and Steen so shaken up. The ground beneath their feet is poisoning the water.
And wait, it gets worse. Because it wasn't just about babies, was it? The teacher dropped some brand new research on them about the long-term risks.
Yeah, this is the part that's scary for everyone, not just infants. A study from the Danish Cancer Society actually linked nitrate in drinking water to dementia.
Dementia, that seems like a huge jump.
I thought so too, but the numbers are significant. They found a 14% higher risk of dementia for people with high nitrate intake from water.
14%. That's not nothing. That's a real signal.
It's a very real signal, and it sort of fits with other things we know. High nitrate is also linked to colorectal cancer, so bowel cancer, and stomach cancer. It's the same reason we're told to be careful with processed meats.
The preservatives and cold cuts, right?
Exactly. E249, E252, those are nitrates and nitrites. We add them to stop botulism, which is great, but the trade-off is this increased long-term risk.
I do think it's important to make one distinction the source brings up so people don't suddenly start fearing spinach.
Oh, absolutely. Yes. Nitrate from plants, from vegetables, is actually good for you. It's linked to lower health risks.
How does that even work? It's the same chemical.
It is, but the plants come with their own protection package. Antioxidants, vitamin C. They seem to stop the nitrate from converting into the nasty stuff in your gut. So salad is good. Nitrate-laced water, not so good.
So on top of blue babies, Kesser and Steen are now thinking about dementia and cancer, and they're also worried about the local fjord. It's not just a human health issue.
No, the whole ecosystem gets hammered. All that nitrogen runs into the water and feeds these huge algae blooms. They grow like crazy, then die, and the decomposition process just sucks all the oxygen out of the water.
Dead zones.
It's total dead zones. The fish die, the insects die, and on land, you've replaced all this diverse habitat with monoculture fields. It's a mess.
Okay, so that's the heavy lesson. The water's poisoned, the fjord is dying. It's enough to make you just want to give up. But these are nature and innovation students. They don't just get depressed.
No, they don't. And this is my favorite part. We're back in the snow. Kesser's holding one of those funny little cones, an ecological, and he has his light bulb moment. This is the answer.
The alder tree.
The red alder, or reddle, to be specific.
Tell me about this tree. What makes it the hero of this story?
Well, for one, wood does this amazing thing. When you cut it, it's light-colored, but as soon as the air hits it, it turns this deep orange red. That's where the name comes from.
And its habitat.
It loves the places other trees hate. Wet, swampy, miserable ground where other trees would just drown. The alder thrives in it.
Okay, and that's the key, right? That's its superpower.
That's its superpower. Because the alder has a partner, a bacteria in its roots called Frankia. It forms this symbiotic relationship.
So they help each other out.
They do.
Yeah.
The bacteria can pull nitrogen right out of the air and feed it to the tree. But the most important part for Kesser's plan is where they grow. They grow in those wet buffer zones between the fields and the streams.
So they can act as a filter.
A living biological filter. That's Kesser's idea. You plant these trees, these pioneer plants, in those soggy areas. And as the nitrate-heavy water runs off the fields, the alders and their root systems intercept it, they process it, they clean it before it can poison the fjord.
So instead of a billion-dollar treatment plant, you just plant a forest.
You use nature to fix a problem that innovation created. It's literally nature and innovation.
I just love that image. Kesser standing there, freezing, holding this tiny cone that's basically a miniature water purification plant.
And he's excited. He's telling Steen, imagine this, a whole row of them. They filter the rain filter regnant. They clean the soil.
What about Steen? Is he buying it?
Oh, he's buying it, but he's also fact-checking on his phone. And then you get this great, authentic moment where he just yells, "Verfanden de Kesser!"
Which is a very enthusiastic, damn it, Kesser, but in a good way.
A totally surprised, amazed way. Because he finds out on Google that the Danish red alder, specifically a seed source called Grosten, is world famous.
Get out of here! A celebrity tree!
In the forestry world, you bet. The Grosten alder is considered so genetically superior that it's exported and planted in Japan.
Japan. They're importing Danish alder seeds.
Yep. And these two kids are just standing in the snow, realizing the weeds they've been walking past their whole lives are actually a premium international product.
That's incredible. Talk about validating your idea.
It totally does. It proves they're not just messing around with pine cones. This is elite stuff.
So they have the seed, they have the plan, but you can't just stick it in the ground and walk away, can you?
Not if you want it to work well.
Yeah.
And these guys are serious. They start talking about the official plant propagation protocol.
Sounds very technical.
It is. They're getting into the weeds, so to speak. They're talking about how You check if the seeds are ready by twisting the little cone structure, the straw ball,
The twins test.
the twist test.
Yeah.
And they find out the best seeds are always in the top third of the tree.
Which is a bit of a problem for two kids in the snow.
A bit of a problem, yeah. But they're focused on the next step, which is the really clever part. They need vernalizing.
Vernalization, what is that?
It means making it spring. Basically, the seeds are dormant. They have to go through a cold period, a winter, before they'll wake up and germinate.
So they have to fake a winter in the fridge.
Pretty much.
Yeah.
That's cold stratification.
Right.
You put the seeds in a damp bag in the fridge for 3 to 5 weeks. That breaks the dormancy. You take them out, and the seed thinks, hooray, spring is here, and it starts to grow.
I love that. They're going to start a forest in the vegetable crisper.
It's DIY environmentalism at its best. And Kesser even has a backup plan. He says if they get stuck, they'll just ask Dr. Shigo on Zoom.
Who's Dr. Shigo?
Well, Alex Shigo was basically the father of modern arboriculture, a legend in the tree world.
Oh, wow.
The only problem is he passed away in 2006.
Oh, so that Zoom call might be tricky.
I think it just shows how deep they've gone. You know, they're talking about the giants of the field. It shows their confidence.
It really does. So let's just pull back. We went from a deer track in the snow to this massive agricultural crisis causing blue babies and dementia, and we've landed on two boys with their pockets full of seeds, planning to use the family fridge to build a biological shield for their town.
It all comes down to observation, doesn't it? Most of us would see the nature, the deer, the snow, but because of the innovation part of their class, they saw the whole landscape as a system.
A broken system.
A broken system they could actually help fix. They didn't just get mad or depressed. They looked for the root L. They looked for the solution that was already there.
And that's really the heart of it. This huge, scary nitrate belt problem feels overwhelming. But the fix starts with something you can hold in your hand, a tiny seed that just needs a little cold, a little care.
And then it becomes a tree that can filter the rain. Feel regnin.
It's beautiful. They're using nature's innovation to solve our innovation problem.
And hey, if those Groston seeds are good enough for the forests of Japan, they're definitely good enough for a fjord in Jutland.
Absolutely. So maybe the takeaway here is to look down once in a while, look at the stuff on the ground. You might just be stepping over the solution to a problem you didn't even know you had.
Nature usually has the answer. We just have to know how to look.
Kesser and Steen clearly do. Well, that's our deep dive for today. Stay curious, watch your step, and we'll catch you on the next one.